The last unit in Math 110 is geometry. And a lot of times when I say the word geometry, students kind of groan. And part of why they groan is because what they remember is doing proofs in high school. So that when you say geometry, that's kind of what they're thinking about. In this class, that's not where we're going. What we're going to do in this section of geometry is we're going to look at how we can use the concepts in things that we do. So we're going to look at area and surface area, those kinds of things we need if we're going to put carpet down in our house or if we're going to paint. And we're going to look at things like volume. If again, I want to fill that raised bed that I just built, I need to know how much soil I need to order it in order for us to actually fill that. Or if I'm going to put bark dust around, I need to have a good estimate of how much I need so that I don't order way more than I need or I don't order less than I need. So that's really going to be our focus with geometry. There are a couple other aspects of geometry, in particular symmetry, which we actually are going to end this class with looking at how art and math connect. And I think you'll really enjoy that and really see how math isn't just formulas and left brain thinking, but math is also just about the beauty of what exists in this world. And I think some artists would really admit that there are many concepts of math that they use in their work. I think for me it's kind of interesting because I never really saw that till I started teaching math, and then I realized that my creative side is really impacted by my math knowledge. So I love to take pictures, and I think my whole kind of mindset of symmetry and color, how color mixes and all of that is a little bit set in my math mind, my left brain. But I also think that by using that, I found that I was creative too, and that really helped me with both understanding how art works, but also that math isn't just this rote memorization of things, but it is also a really aesthetically beautiful kind of a subject. So geometry is going to teach us a lot about that. So I'm not sure how you were as a little kid, but I remember rocks fascinated me, and I would pick them up everywhere. And when I look at concepts in geometry, in particular, we're going to be looking at a couple formulas for volume and surface area. It's always fascinating to me how we as humans sort of copy or look at things in nature, and then we try to build things from them. And so I think for me these crystals that I have here are really, really cool examples of how within nature all of these shapes that we're going to ultimately be looking at exist. So we've got just these really cool pyramids that exist in this one. We have, I think this one is salt, and I don't know how well you can see it, but these are just like all these cool little perfect cubes. And then this is amethyst, and these are not human made. These are all God made. And if we look at these again, we see a bunch of pyramids, which I think a lot of times we don't necessarily see beauty in math, but I think there's a lot of beauty that exists. It also, for me, is kind of a spiritual thing, that you look at our God who created this really amazing earth and all the things in it, and how we're put here try to make some sense out of some of that stuff. So I wanted to start off by showing you these naturally occurring shapes, and then talk a little bit about how we can use those in order to determine surface area and volume in particular. And I'm not going to go through every single formula with you, but I wanted to look at the shapes that we are going to be using. In particular, we're going to look at a prism. A prism is always going to be defined as a figure that has identical shape on both the bottom and the top, and then is connected with rectangles along the side. Prisms are always named by the shape of their base. So this is a 1, 2, 3, 4, 5, 6 sided, or a hexagon. So this is a hexagonal prism. We can have square prisms, we can have triangular prisms. This is going to be determined. This is kind of a prism, but when it involves circular surfaces, we call it a cylinder. So conceptually, it's very much the same as a prism, but the circle has us actually calculating our areas a little bit differently. We also have pyramids. When we look at a pyramid is going to be defined also by the shape. So this happens to be a square pyramid, and the pyramid would then have sides that are triangular that come to a point. I don't know if you remember what this point is called, but the point on a pyramid is called an apex. And so when we look at these shapes and we start to look at formulas, we're going to be looking at different ways of defining how they're created. Now, when we talk about surface area, we literally mean what is the measure of each of the sides. So it's literally along the surface of this that we calculate surface area. One of the places we would need surface area is, imagine that this is a building on your property, and you are wanting to paint the outside of it. Well, if you knew the surface area of this, it would be easy to know how much paint that you needed to purchase, okay? So that's true for surface area. Volume is really going to be more what we put inside. So let's look at how we determine the surface area of a cylinder. And if we look at this formula, it just kind of looks a little daunting. Surface area is 2 pi r squared plus 2 pi rh. So it's kind of like, where does all that stuff come from? So remember that surface area is where we literally cover all of our figure. So I'm going to cover it here. So all of this figure is covered. And when I undo this, what I notice is that my two bases happen to be two circles. So if I look at two circles, the area of each circle is pi r squared. Now I look at my formula and look, this is just 2 pi r squared. So these are the two circles. It's a little bit tougher to kind of imagine the other surface of the cylinder, but when I open this rectangle up, that this is what covered it, what I notice is that the length or the width of this rectangle is the same as the height of this cylinder. And I also notice that when I undo my rectangle, that the length of this rectangle is really the same as the measurement of the surface area of the cylinder, of the base of the cylinder. So when I look at that and I undo my rectangle, the width is the height and the length is the circumference. What I know is circumference is 2 pi r. So area of a rectangle is length times width. So there's this part of our formula, 2 pi r h, the circumference and the height. So it isn't that these formulas just come out of thin air. These formulas are literally looking at how we can break down the figure into pieces that we already know how to find the area of.